Let us now look at the next section, students. This section contains 2 paragraphs. Each paragraph has 2 questions. Each question has 4 options, out of which only one single option is correct. Okay. So let's first start with the paragraph given for question number 33 and 34. Okay. A solution consisting of 0.1 mole of a non-volatile solute M and 0.9 mole of liquid N is cooled to a temperature T Kelvin until some solid N separates out. Okay, so we had 0.1 moles of M and we had 0.9 moles of N. Okay, it is cooled to a temperature T Kelvin until some solid N separates out. Okay, the solution is then filtered from the solid and warmed up to 353 Kelvin, where its vapor pressure is given to be 670 torr. The freezing point and the boiling point of the liquid N are 278.5 Kelvin and 353 Kelvin respectively. Okay, so the boiling point is 353 Kelvin, and at this temperature the vapor pressure of the solution is found to be 670 torr. Okay, given that the enthalpy of fusion of N is 10.67 kilojoule per mole, on the basis of this information answer the questions that follow. The value of R is given to us, the value of 278.5 whole square is given to us, and the molar mass of N is 78 gram per mole. Okay, so in question number 33 the examiner seems to be interested in the amount of moles of N which is present in the solution after filtering it off from the solid as mentioned in the paragraph. Okay, so if we talk about this paragraph, students, it is given to us that at 353 Kelvin the solution exerts a pressure of 670 torr. Okay, so we know that the relative lowering in vapor pressure will be equal to the mole fraction of the solute. So at 353 Kelvin, which is the boiling point of the liquid N, so the vapor pressure has to be 760. So the relative lowering in vapor pressure will be 760 minus the pressure which is actually exerted, which is 670 upon 760. So this shall be equal to the moles of solute, which was 0.1 upon 0.1 plus the number of moles of N. So we can assume that to be X, students. So this is the moles remaining after the solution is filtered from the solid. Okay, so we have 90 by 760 equals 0.1 upon 0.1 plus X. So we can just use dividendo in this case. We're going to have 90 by 670 equals 0.1 upon X. So students, the value of X is given by 67 by 90. So if we solve for the value of X, students, we're going to have a value equal to 0.744. So this is the number of moles of the solvent which is present in the solution after the solid is filtered out. Okay, so students, if you look at question number 33, we have to mark the answer as option D. Let us look at the next question now. What is the value of the cryoscopic constant of the liquid N in Kelvin kg mole inverse? Okay, students, if we talk about the value of this Kf, it is given by M by 1000 into RTF square by delta H fusion. Okay, so students, this 1000 is for the molar mass, so the molar mass will be put in grams. So this 1000 is for this conversion into the SI units. So students, we put the value of M as 78 grams. So dividing it by 1000 will automatically convert it into kilograms. Okay, the value of R we have to put in the SI unit, students. R is 8.314. Okay, the TF square, TF is 278.5 whole square is given to us. It is 77.56 into 10 to the power 3. So this is 77.56 into 10 to the power 3. Okay, so this has to be divided by delta H fusion. The value of delta H fusion given to us is 10.67. Okay, but the delta H is given in kilojoule per mole, students, so we have to multiply another factor of 1000 over here. Okay, so on simplifying this, we get the value of Kf equal to 4.714. Okay, so for this question as well, students, we have to mark the correct answer as option D. Let us look at the paragraph given for question number 35 and 36. Okay, Qualitative analysis of ions is often done by precipitating the metal ions in the form of their sulfides by passing H2S. The sulfide ion concentration is controlled by adding HCl or NH4OH depending upon the Ksp of the sulfide to be precipitated. So consider the data given. We have Ka1 of H2S is 10 to the power minus 7, Ka2 of H2S is 10 to the power minus 14, and assume H2S concentration to be maintained at 0.1 molar. So for question number 35, it says the Ksp of NiS is 2 into 10 to the power minus 21. What is the maximum amount of Ni2 plus in molar which can be present in a solution containing 0.1 molar H2S and 0.1 molar HCl? Okay, so students, what we have to do is we have to first find out the sulfide ion concentration present in 0.1 molar H2S in presence of 0.1 mole HCl. So students, we know that in the presence of external H plus ions, we can directly find out the concentration of sulfide ions by using the formula. So we have H2S giving us 2H plus plus S2 minus. Okay, so the H plus ion concentration will be 0.1. This is also 0.1. Okay, and it is maintained at 0.1. The value of K for this reaction will be equal to K1 into K2. Okay, so we have 10 to the power minus 21 equal to 0.1 whole square into sulfide ion concentration divided by 0.1. Okay, so in solving this equation, students, for the value of sulfide ion concentration, we have S2 minus ion concentration equal to 10 to the power minus 20. So students, in the presence of 10 to the power minus 20 molar sulfide ions, maximum amount of Ni2 plus can be found out. So we have Ni2 plus ion concentration into the sulfide ion concentration equal to 10 to the power minus 21 into 2. So in solving this expression, we can put the value of S2 minus, which is 10 to the power minus 20. So we can find out the value of Ni2 plus ion concentration. It comes out to be equal to 0.2 molar. Okay. So for question number 35, students, we have to mark the correct answer as option B. Let us look at the next question now. Question number 36. To a solution containing 0.1 molar HCl and the H2S concentration maintained at 0.1 molar, the Ni2 plus ions are slowly added and after some time the precipitation starts. Select the correct statement about this precipitation. So if we talk about the net reaction happening in this system, students, so we have Ni2 plus ions which are slowly added. They react with the H2S to give us NiS and 2H plus. Okay, so this net equilibrium can be thought of as consisting of two individual equilibriums, which are H2S dissociating into 2H plus and S2 minus in the presence of external H plus. So this is external. So this equilibrium will be giving us correct answers in the presence of external H plus. Okay, and then we have Ni2 plus ions reacting with the sulfide ions giving us NiS. Okay, so now students, as Ni plus is added, so when it is added, this will shift more and more in the forward direction. So due to the shifting of the equilibrium in the forward direction, the H plus ion concentration is going to increase. Okay, so if we talk about the pH, students, the pH of this solution will decrease due to the formation of more H plus ions. Okay, and if we talk about the sulfide ion concentration, students, so as the H plus ion concentration will increase and the concentration of H2S is kept constant, so the sulfide ion concentration has to decrease, students. So as Ni2 plus is added, this reaction will shift in the forward direction, which will lead to the formation of more H plus ions. So as a result of formation of more H plus ions, students, the pH of the solution will decrease. And if you look at the second equilibrium, which will also be established in the system, as the H plus ion concentration increases and the H2S is maintained at 0.1 molar, so this has to decrease as the value of H plus ion concentration increases to satisfy the K equilibrium values. So the pH of the solution decreases, whereas the sulfide ion concentration, it also decreases. Okay, so if you look at the options which are given to us, the first option is not correct. If we talk about the second option, it is the correct answer, students. It says that the pH of the solution decreases, whereas the sulfide ion concentration also decreases during the course of the reaction. Okay, so the correct answer to question number 36 has to be marked as option B. So this is it for today, guys. I hope the solutions were clear to you. Thank you.